Okay, welcome everyone to this co-hosted webinar on behalf of the UK International Centre of Excellence in Sustainable Resource Management, co-hosted with our partners at the UNECE, who we'll be hearing from very shortly. Next slide, please. Okay, so this is our agenda, but it will be exciting and really informative, so I'm really looking forward to it. I'll be kicking off proceedings, or that's what I'm doing right now. Dario will then talk to us about the priorities for the UN and how the International Centres of Excellence are supporting them in their mission. Ulrich will be talking to us about some tools that have been developed by the UN and their context within the Critical Raw Materials Act. Jeremy, who's joining us from the United States, will be talking to us about the journey there and the key considerations around recycling. Antonia will be talking about the journey and the challenges that exist with the the scrap processes within the UK. Peter will be giving us an environmental look at the customer requirements for these materials, and I'll then close by talking about how we can implement or try to solve this very complicated picture that we'll be painting through the course of the webinar using the tools that have been introduced by both Dario and Ulrich. Next slide, please. So I just wanted to say first that we're going to be talking a lot about recycling today, but we all acknowledge as a panel and as a community, and particularly within the International Centre of Excellence in Sustainable Resource Management, recycling is just one vector of the circular economy, and that the solution to deliver a successful and thriving and sustainable circular economy practices really required many more interventions, of course, in the product design space and in reuse and recycling, remanufacture. And so, but nevertheless, this remains a very significant and important challenge that we must address in the short term. And hopefully, as time goes on, once we solve this problem, recycling will become less and less critical to the circularity journey. I'm just going to close by my little introduction just by pointing out a couple of points of context for this whole discussion. Obviously, we're a UK International Centre of Excellence in Sustainable Resource Management, but we're interested in the international context that exists, and of course, steel is a globally traded commodity, and therefore the international picture is becoming increasingly important. Some key points of principle I just wanted to introduce before we hear from all of our speakers today. First one is that in terms of production, there's always quite a healthy and vigorous debate, I would say, about which production method is the best. But irrespective of the vector of energy that is used and the method of steel production that is used, what no one can argue is the fact that ore reduction to produce metal is significantly more energy intensive than remelting end of life material. Okay, and so that's the first point. The second point is that the context here in this webinar is about scrap, but we should point out that the demand for end of life steel will be something like, or for steel, sorry, in total will be something like about 2.2 billion tons under the IEA Sustainable Development Scenario, and scrap supply is only about 1.3 at that same point in time, around 2050. So that's a billion tons deficit, and critically from a global equity perspective, that's unequally distributed. So it's significantly concentrated in those economies that have already developed over many decades. And so the access to this material, although it's a very easy source of decarbonisation, is unequally distributed, and that presents differences in opportunity to use this as a decarbonisation lever. And in the UK, in this context, we've got loads of it. We're in one of those areas where we're very rich in this material. And then finally, there are trends in trade. So there are a lot of people looking to reshore supply and be more responsible about how they use this. That has an implication on this challenge. The security of supply is becoming increasingly important in a ever more destabilised world, and there are attempts at being able to manage this process at national levels, including the UK Steel Strategy, but also the EU Steel and Metals Action Plan as just two examples. Those are going to require management and measurement if they're going to be successfully delivered. And so this is an important context for the rest of our discussion today. And that leaves me with great pleasure to be able to introduce Dario, to talk about how the UN are viewing this challenge and how they're supporting us, and we're supporting them through the International Centre of Excellence and Sustainable Resource Management Network. Thank you, Dario.
Thank you, Cameron, and good morning, good afternoon to all of you, and glad to be here and to talk about such an important issue. Maybe next slide we'll go straight into the content. So why the UN? I mean, obviously resource management is not only a huge economic development opportunity, but as well it has a huge environmental and social impact. And we've been working on resource management, on sustainable resource management actually for decades right now. And as you can see, particularly over the last couple of years, it has become politically very, very relevant. Even the UN Secretary General has last year had actually called for a high-level panel to look at critical energy transition minerals, which is a subset, of course, of the overall resources available, to come up with principles and recommendations on the basis of the work that we've been doing around that on how to make resource management more sustainable. As I said, we've been working through the expert group on resource management for decades on issues, and the two main products, if we want, or outcomes of the work that the group of experts has been conducting is the United Nations Framework Classification for Resources and is the United Nations Resource Management System. And what are those? One, well, there's clearly, I mean, you can understand that from their titles. So the classification the UNFC is a classification methodology that takes into consideration not only economic and financial viability aspects, but environmental and social, and the degree of statistical confidence in those reserves and deposits. And it has been deployed across a number of resources, whether are primary resources, energy and mineral resources, or anthropogenic resources, like steel or energy projects for such. And that the idea behind that is to provide the world and all the stakeholders around that with a unique language to be able to communicate and to be able to take decisions across different sectors, across different stages of those projects, and across different commodities and jurisdictions. The second one, the United Nations Resource Management System, builds upon the classification method. And once you have taken a decision to invest in a project, whether it's an extraction project, which is refining or whatever industrial project, is how do you actually make sure that that project is undertaken in the most sustainable way? And that's what is called a management system. These methodologies are being deployed and taking up at global level. I mean, as Cameron mentioned before, the EU Critical Raw Materials Act mandates for the EU 27 member states the use of UNFC when looking at their natural resources and their mineral deposits for the critical energy transition minerals, but as well when looking at projects with non-EU member states, such as the one that had been highlighted recently and are part of the strategic partnership that the EU has signed up with a number of countries around the world. The African Union has already taken as well UNFC. They have adapted, of course, to the African needs, and they call American Park. But a big role in the dissemination of these tools is played by the International Centers of Excellence on Sustainable Resource Management, of which the UK is one. Next slide, please. And so the network, the number of these centers of excellence around the world is growing. The UK, where Cameron's University, Swansea, and the other partners that are hosting today's webinar are part of they have established it with our support and with our help, and we joined it, but this is their initiative, is actually one of a larger network, as you can see on this map, that is starting to cover the whole globe. Some of them are of a regional nature, some of them are of country nature, some of them are focusing on mining or extraction, some others are such as the UK one, are focusing instead on the circular economy. But the strength of having all of these centers around the world together in a network is that they can exchange best practices, they can work together on issues, they can learn from each other. Next slide. And this is so basically, what is the role of these centers of excellence and what is the role of the network? It's platform for cooperation, as I just mentioned before. So in this case, of course, the UK is at the forefront of bringing forward the circular economy and showing the rest of the world, you know, how to deal with circular economy and how to enhance, particularly in developing countries where it's a very nascent idea and a very nascent policy from that perspective. Capacity building, this is as an example of the capacity building, whether it's seminars, papers, training opportunities, etc. They use the knowledge hub that we have established in our website, which is plenty of knowledge and training material for the different stages of preparation of people around UNFC and UNRMS, which is available to everybody. And of course, they drive impact. They are there to drive policy. They're there to drive industrial decisions. They're there to drive sustainability concept across resource management, but not only as well across the industry and as well. And so certainly that is the main, with the biggest impact and the biggest objective of the centers of excellence in driving sustainable resource management. And with that, I'll give you back the floor, Cameron. Thank you very much. And thank you all.
Thank you, Dario. I just wanted to remind everybody that there's the opportunity to ask questions at any point through the webinar. We would like you to use the Q&A if possible, because it makes it easier for us to manage that and ensure that everybody gets say. Without further ado, I'll pass from Dario over to Ulrich Kral, who is the co-chair of the UNECE ETRM Anthropogenic Resources Working Group, to talk about these tools. Thank you.
Yeah, good afternoon. Does it work, sharing the screen and hearing my voice?
Yep, you're coming through loud and clear, Ulrich, and everyone can see.
Okay, that's great. Thank you, Dario, for already introducing the two most prominent tools of the UNECE Expert Group of Resource Management. It's the UNRMS, the United Nations Resource Management System, and the UNFC, which is a classification for projects. Next slide, please. I briefly give you an overview about these tools and then make a short deep dive into the UNFC. On the left-hand side, you see the key basics for the UN Resource Management System. Of course, this, let's just say, UN tool is used to optimize resource utilization in a region or for a certain value chain, and is applicable to minerals, to energy, and also to recycling materials. And if I'm just thinking about the steel industry, which needs tremendous amounts of energy, how to manage this, how to secure energy supply in order to produce valuable products in terms of steel, how to get the critical raw materials from which are used as alloying elements for the steel. So all these aspects can be covered in the UN resource management system, and the resource management system includes about 12 different principles that should be considered in order to optimize the resource utilization in a value chain or a region. This brings me also to the second tool, the UN Framework Classification for Resources. Well, this tool is now focusing on concrete projects. Project means projects under development in the mining sector or even in the recycling sector. And it standardizes the communication of the maturity level of these projects, and you know how far are these projects from the market, which are currently under development. And it also communicates the quantities that are associated with these projects in terms of tons. Why is such a tool that focuses on mineral projects or recycling projects of relevance? Of course, it's basically used to de-risk the development of mineral and energy projects. Of course, companies who have multiple mining projects in the pipeline or also recycling projects in the pipeline, they have to manage this project portfolio. So where to put the investments into which projects, where are the main barriers, and which projects should profit from capital allocation in the future. The information that is provided by the UNFC can also be used for national resource management, to manage, for instance, resource endowments, and also to shape the future of raw material policy making in a country or even in the European Union. How does it work, the UNFC? Basically, the UNFC provides a standard to classify these projects under development, and it considers three major criteria. The first one is the environmental socioeconomic viability. The second is the technical feasibility, and the third one is the degree of confidence of product estimates. So as you can see, it's really a 360-degree view on projects under development. Next slide, please. Right. If we make a short deep dive into the UNFC, you see the classification of the projects according to UNFC on the left-hand side. This becomes clear when you look to the column in the middle where it's titled with class. There are different classes of projects according to the maturity level. It all starts with viable projects, followed by potentially viable projects, then you have non-viable projects, and you have prospective projects. And depending on the project evaluation, for the socioeconomic viability, for instance, on technical feasibility and the degree of confidence of the product estimates, you either get a viable, a potentially, or non-viable, or a prospective project. And this really makes sense if you're not having only one project. It makes sense if you have multiple projects, or if you want to monitor the involvement of the development projects over time. On the right-hand side, you see a concrete application of the UNFC in the UK. It was Tom Byde and his colleagues from the British Geological Survey who created and developed a minerals inventory for in-ground resources in the United Kingdom. And this example is just for tungsten in the UK, and you see the categorization of different quantities, tungsten quantities in the UK according to the UNFC. So what is here labeled with E is the environmental socioeconomic viability. And you see that about 60,000 tons, this is the first row, are classified according to the E, F, and G, which means the environmental socioeconomic viability. F is technical feasibility, and G is the level of degree of confidence of the product estimates. And the first row shows you that this 56,000 tons of tungstens are in ground, and the development and operation are expected to become viable in the foreseeable future. It means it's not ready for production right now, but the evaluator expects that it becomes available in the foreseeable future and can be used by industry. If we look to the technical feasibility of these mineral resource endowments, we see that the technical feasibility of a development project has already been confirmed. This means that the feasibility study has been developed and potentially also published, and this feasibility study confirms the technical considerations that can be realized. And for the last point is the degree of confidence of the product estimates. It already says that there's a high level of confidence on these product estimates. And this type of information is available for other quantities as well, which might have a lower maturity level. And this is of special interest because then you can look to the second level of detail in the of the UNFC, which is not shown here, but the second level of information shows you the barriers in order to bring these projects to a higher class, to shift them from a non-viable or potential viable status to a viable status. And the UNFC provides this inventory with a global standardized terminology. Next slide, please. My last slide is about critical raw materials, the link to the CRM Act and to the UNFC. So how does this all fit together? As you might know, that steel requires alloying elements. This could be molybdenum, it could be zinc or magnesium or other type of elements that are used to improve the specifications and the performance of the steel. And quite a lot of number of these alloying elements are critical. They are critical according to the European list, but also according to lists in Canada, the United States, Australia, and other countries and regions. And securing access to these alloying elements, which are some of them are critical, is essential for the steel industry in order to provide the performance of the steel. And the policy response, at least in the European Union, is the CRM Act, because the CRM Act aims to guarantee or enable the access of critical raw materials for the industry. 2 points from the Act. The first one is the Act defines benchmarks for the critical raw material supply by 2030, which is in, let's say, 4 years. It defines benchmark in terms that 10% of the CRM supply should be sourced from mining. 40% of the CRMs should be processed in Europe, and about 25% of the CRMs should be sourced from recycling processes, which is quite ambitious, let's say. And the UNFC, which is the tool that is developed and promoted by the UN Expert Group of Resource Management, and which has been briefly introduced in the previous slide, can be found in the Act at 4 times. The first one is in Article 7, it's about strategic projects. So the industry can apply for the recognition of their recycling or of their mining or of their processing projects to become strategic in the European Union. So what's the benefit of a strategic project? There are 2 benefits. The first one is that the companies profit from easier access to finance for the development of these projects, either mining, recycling, or processing. And the second is that the time for approval by the authorities is limited per a certain time. It's fixed. The UNFC has to be used to classify exploration programs. This especially addresses the mining sector. The third point is the UNFC is mandatory in order to report the viability of mining, processing, and recycling projects in a country. It's an obligation by the member states to provide this information to the European Commission, and they have to use the UNFC, the terminology. So it means the terminology to classify these mining, processing, and recycling projects. And the fourth point is also worth to mention because there are some extractive waste facilities that already include CRMs. They might not be economic viable for recovery in the past, but this might change, especially when the framework conditions change and technology upgrades are in place. So there is also the mandatory use of the UNFC to classify storage facilities in the European Union. That's all. Thank you for listening and thank you for your attention.
Thank you so much, Ulrich. Quite a complicated series of topics there and tools, but really clearly, thank you so much. So before we come to think about how these can be used to and applied to the circularity of steel and steel recycling in particular, let's hear from Jeremy from the United States, who's come to tell us about their long journey that they've already been on over there for the last few decades and what they've learned and what we can learn from them. Thank you, Jeremy.
Thank you. Good afternoon, everyone. Next slide, please. So if we look at advances in EAF technology, and we always have to look at the raw material demand with respect to the technology, further decarbonisation of EAF is heavily dependent on renewable energy and higher quality raw materials. The higher the quality of the raw materials, the more energy efficient we can be in the electric arc furnace. And there are challenges around the renewable energy side of things. I'm not going to spend a lot of time on that. There's a lot of focus on hydrogen-based processes, but these are unlikely to be implemented before about 2035, except in regions that already have a very low carbon footprint energy available, like Scandinavia and Canada. Next slide, please. So scrap is a decarbonisation lever. 100% scrap-based operations utilizing EAF technology already have a very low CO2 footprint. The footprint can be lowered through improvements in efficiency and improvements in iron yield, but we have to understand the properties of the scrap to optimize its so-called value in use. Increasing levels of scrap residuals like copper, tin, nickel, and molybdenum are a concern and require varying amounts of ore-based metallics to allow recycle. These are elements that can't be removed from the steel bath. Next slide, please. So it's impossible to talk about decarbonization without considering raw materials. The single biggest cost for the EAF steelmaker is the metallic charge. And the future of EAF steelmaking is about maintaining a sustainable balance between ore-based metallics and recycled scrap. The more we do to improve scrap quality, the less dependence we have on ore-based metallics. So that leads to greater sustainability and improved circularity. It goes without saying that the maximum recycled steel scrap can only be achieved by improving scrap quality. Next slide, please. So these are some of the challenges that we faced over the last few years. And it's important to know, even though under the guidelines now, scrap is treated as having a zero CO2 footprint, but realistically, the CO2 footprint of recycled scrap is dependent on the scrap quality. And so in Europe, CO2 taxes will drive us to deliver a higher quality scrap product. Next slide, please. But we have to look at these contaminants. And I've already talked about the residuals. Extraneous materials like plastics, non-ferrous metals, wood, oil, grease. These are the greatest contributor to environmental issues associated with electric arc furnace operation, and also contribute to the CO2 footprint. So it goes without saying that we should be trying to remove these materials from the steel scrap before we put the scrap in the furnace. We don't want to use the EAF as an incinerator. Then we also have another one, which is dirt. This results in increased flux requirements, increased energy consumption, yield losses, and decreased productivity. 1% dirt increases the CO2 footprint by 43 kilos per ton of liquid steel. Next slide, please. So this is just an example that one of my colleagues put together for one of our clients, where we actually looked at operation as is, improving endpoint control, which is essentially not overblowing the steel, not generating too much FEO. But when we start to control the dirt level in the scrap, we see massive cost improvements as well as in environmental and operational benefits. Next slide, please. So the scrap grades that can be upgraded. Well, the scrap grades, and I'm using the North America designations. So we have fairly well-defined categories in North America because we've been operating EAFs essentially since the end of World War II. Well, actually during World War II. So the scrap grades are the greatest amount of free copper, which is copper that's not contained in the steel itself, but is copper that's coming along for the ride in the recycled material, are shredded and heavy melt. Extraneous materials can be associated with almost all scrap grades, but again, predominantly shredded, number 1 and number 2 heavy melt. And dirt can be associated with all scrap grades, but again, predominantly shredded HMS. And to put it in context, some export scrap can contain as much as 7% dirt. Next slide, please. So we've actually been working with some equipment suppliers in Europe. This is a unit that's supplied by a company called Secon. And we actually look at concentrating the metallic Fe and removing, decontaminating the scrap and isolating other materials like copper, nickel, and chrome. The nickel and chrome, of course, in stainless scrap. Next slide, please. In North America, the short-term solution has been dilution. This evidenced by the high percentage of ore-based metallics in the charge mix for flat product producers. Essentially, we dilute the residual levels in the scrap that we recycle, and this allows us to essentially reach a balance which is acceptable for the products we're trying to make. But the challenges are that the availability of prime scrap is shrinking in many of the mature economies as manufacturers become more efficient, generate lower quantities of scrap. And then we also have some industry sectors now calling for green steel, so-called cleaner products made without pig iron And a big push in North America was the Ukraine conflict, which resulted in a shortage of pig iron. And so faced with that shortage, several of the larger mini mill groups embarked on a program to upgrade scrap quality. Next slide, please. So without this upgrade, our shredded was probably running at about a 0.25 to a 0.3 weight % copper. The actual dissolved copper content of a lot of the shredded automotive is 0.06 to 0.1 weight %. So the free copper comes from the electronics, the wiring harnesses, etc., that are part of the car. So more copper can be removed by repeated shredding and magnetic separation and enhanced equipment maintenance. Nucor and Steel Dynamics are currently producing shredded material with about a 0.16 weight % copper. Of course, a big concern is that electric vehicles contain 3 times as much copper as conventional automobiles. So part of the circularity is also putting much more thought into designing steel products to ensure that copper and other bulk residuals can be removed easily prior to recycling at the end of life. So greater effort must be made to separate the free copper. Next slide, please. So this is a table that basically shows that if we do nothing by currently we're running at about a 0.25 to a 0.3 weight % copper on average in all of the scrap that's recycled. And you can see that to make certain products, we need to add ore-based metallics. Well, if we get out to 2050, where we expect the copper content to average 0.5, then you can see that even to make products like rebar, we would have to use 20% ore-based metallics in the mix. Next slide, please. So the steps to upgrading include larger magnetic separators, adjusting gaps, typically aiming for higher density, and we install instrumentation to monitor the copper level in the product stream. Next slide, please. The trials that we conducted with Seacon in Europe, you can see we removed a considerable amount of free copper, nickel, chrome, lead, phosphorus, and it had a huge impact on both a reduction in carbon footprint and a reduction in energy requirements. Next slide, please. So one of the major obstacles to upgrading scrap quality is the argument that the cost would outweigh the benefits. We've developed a value and use model that we use to assess this. And what we have found is that the cost benefits greatly outweigh the cost. To reduce the copper from 0.35 weight % to 0.16, the cost is about $4 to $5 per ton. And then the higher density shred that results is typically much better for EAF operations. Next slide, please. So we must drive towards cleaner raw material input to steelmaking. Steel scrap plays a critical role and can improve the value in use. Upgrading costs are more than offset by the reduction in CO2 footprint, in EAF efficiency improvements, and reduced environmental concerns. We already have the equipment available to upgrade scrap quality, but we need more involvement from scrap processors and manufacturers. Designing for end of life is critical to achieving cleaner recycle streams, which will lead to greater recycle quantities. And lastly, OBMs enable greater scrap recycle, and demand will remain high for the foreseeable future. Next slide. Okay.
Thank you so much, Jeremy, for bringing that perspective from all of those years of experience of doing this within the US. And we'll return to this in the panel for sure. So now we pass over to Antonia Grey from the British Metals Recycling Association to talk us through the perspective from the scrap processing side. Thank you.
Good afternoon, everyone. Next slide, please. If I may, I'll just tell you a little bit about the BMRA. We are the only trade association in the UK that represents metal recyclers. We have some 300 companies in memberships, and they tend to be small family-run businesses right up to multinational organisations. Our member companies handle about 90% of the scrap arisings, and that can be the general metals, so from construction demolition, end-of-life vehicles, and waste electrical and electronic equipment such as small domestic appliances and large domestic appliances like fridges and washing machines. Members deal in both ferrous and non-ferrous metals and are involved in a number of processes to refine those metals. Next slide, please. So green steel is essential for net zero decarbonisation, and it has to be recognised that recyclers have a huge role to play in the steel sector's journey to net zero. In and of itself, the sector has very low emissions. As you can see, just 0.07 of the UK's emissions. And I think when we transition, as you will see in the second figure, to electric arc furnaces, then that amount comes down even more. And we are part of that. They can benefit from our scope 3s, just as we are a little bit hamstrung by the scope 3 of the emissions from the steel sector. Next slide, please. So apologies, it's a little bit of a confusing slide, but it's just to give you a basic idea of how the metals recycling sector works. As a sector, it's like a triangle. You have a lot of small businesses collecting and sorting the metals, processing and moving it forward and up through the chain until you get to operators that run shearing and baling. Now, some of that shear will be HMS 1 and 2, as mentioned earlier by Jeremy. That will be sent domestically to smelting directly or exported. Then we come to the shredding process. It's a very basic image courtesy of BIR, which is the Bureau of International Recycling. A car goes into the shredder, it goes through the mill, lots of hammers. It's reduced into smaller pieces, then through things like magnetic separation, lasers, eddy currents. It's separated out into 3 fractions: ferrous metals, non-ferrous metals, and residue. And as you can see, the images on the right-hand side, you've got 3B, so basic shred of steel. Then you've got a mixed metals, which is copper and aluminium, and they'll be sent to a downstream separation plant to pull out. And then you've got the automotive shredder residues, it's known, shredder residues, which will go for further processing and then appropriate disposal. It's not perfect, we know this. We know there is free or extrinsic copper in the mix. So obviously we need to think about this. Next slide, please. So there are 3 things to think about. Well, there's lots of things to think about, but if we bring it down, there are 3. Not necessarily in the order I've given, but it seems to make sense. So design. Next slide, please. So just as Jeremy said, we need to go back. We need to go back to the designers and make it not only easy to reuse, repair and remanufacture, but also to recycle. They need to stop manufacturing for ease of manufacture and think about end of life. They can make it simpler, and that's why I have a gecko on my slide. Simply because we need to think about autonomy in products. Just as a gecko will lose its tail, surely we can come up with a way so that, just as, again, as Jeremy said, we can pull out the wiring looms from a washing machine really easily. There's no way it comes out in one cassette and then it's put to one side. So I think we need to just make it a little bit easier to pull it apart and recycle. And I think we also need to rate products on recycled content and recyclability. Just as we have energy uses now, A, B, C, D, I think we need to look at this too. I think it's important that we rate them, and so people know that this is, and I think this could be mandated at a higher level to say that you have to sell it with the green credentials. Next slide, please. So perhaps the most important challenge that we face, again, Jeremy's alluded to much of this, but we know that we have to change. We know that we need to meet the needs of a changing steel industry, and we know that it's becoming about chemistry. As Jeremy said, technologies do exist, as he said, but they come at a cost of adaptation and having better space. We need to have better segregation, yes, and that comes again with space. There's changing throughput. They exist. Jeremy said to it, you have to run it through twice, or you put it through a different separation method. And we need to adapt downstream separation as well. I will make one caveat on behalf of the metal recyclers. I have consistently been told that the income that scrap operators will make from extracting the extra copper will cover the costs of upgrading and reprocessing. It's not working that way. There's more regulatory burdens that we face. For example, copper fines are designated as a hazardous waste. So we need to change our processes, but we also need to have more permitting, hazardous movement permits, all this sort of thing. So there's additional costs. And speaking of which, we can go to the next slide, please. So I want to talk about externalities. There's a lot of issues that we are dealing with as a scrap processor. In the UK, we've got high electricity costs. I know that's very specific to the UK, but not specific to the UK is the cost of dealing with and moving, as I said, hazardous waste. There's a lot of hazardous waste being found. So shredder residue is a hazardous waste. That's because of the TPH, copper fines, and it's not just copper. We're going to be looking at zinc, going to be looking at nickel. And then there's a growing list of persistent organic pollutants, so POPs. They're found in cars, in the bumpers, in the block between the engine and the passenger cabin, in the seat foams, and they have to be irreversibly destroyed. So another cost to pull them out and to deal with them. And then again, as Jeremy said, changing nature of scrap. Cars are becoming more plastic, less metal. And so we have to adapt for that. We have to see where we're going to get the scrap from in the future. And finally, again, I'm going to come back to it. You get what you pay for. We are having conversations with steel producers saying that we can reduce this grade that you're asking for, very low copper, about 0.1, as we said, but that does cost. We have to deal with the running through twice and extra separations. And I think it's also time to begin to tell consumers that the days of the cheap white goods is probably over. So next slide, please. So I think it's important to say that we don't just deal with steel, and we've had previous speakers talking about resource management, and there's increasing regulations and what we need to target and what we need to manage and recapture. So you've got all the infrastructure and alloys metals that we've spoken about previously. You've got the battery metals, you've got the catalytic converter metals and the magnet metals, just by way of example. Now, catalytic converters, we're doing a great job on that, getting the PGMs out. Magnets, Birmingham University have actually just opened a large-scale plant to deal with magnets. And interestingly, we started to speak to them as early as 2017 about this. So you can see going from lab work to full scale, that takes time. So we need to build that time, that acceptance that it takes time to develop this sort of stuff. So if we can go to the next slide, please. So this is the one that I think we need to flip things on their head. We are reliant on a linear, and yes, we will be with the dearth in scrap globally. There will always be the need for primary ores, but surely it should be focus and reliance on recycling and then top up with primary. I also think we need to be realistic and sustainable on a global scale, because if we're not, then we can be setting targets too high that aren't yet achievable. And the global scale the goal for one material shouldn't adversely affect another. They all have to be really created as equal, because they are everywhere in built materials. So the more we learn, the more we can extract, but we need to be careful. And I think that we also need to add procurement into resource management. Governments need to say that they need to green procurement, stop using reliance on linear and say we have to buy green. So yeah, that's the end of mine. Thank you very much.
Thank you so much, Antonia, for providing that additional insight. It's already raised a couple of questions which we can pick up in the panel. Swiftly, just because we're running a little bit over time, over to Peter, who's going to talk to us about the customer perspective and how this is benchmarked and compared currently in the current environment. Thank you, Peter.
Thanks, Cameron, and thanks, Antonia, for that interesting talk beforehand. Morning, good afternoon, good evening to all on the webinar. Yeah, next slide, please. So I'm going to give a perspective of a steel company, Tata Steel, I work for. Very brief introduction. We've got global assets in mainly in India, in Thailand, in the Netherlands, and the UK. But for most of this talk, I'll be giving more of a UK perspective. Next slide, please. So we've obviously talking very much about circularity here, but in the case of steel industry and scrap, circularity is very, very closely linked to decarbonisation, as we've already heard. So why do we have to transform as the steel sector? Well, I think people will very, very well know that steel contributes an awful lot of global anthropogenic CO2 emissions, something like 8%, according to the World Steel Association. But also that feeds through from our customer base across automotive, engineering, construction, packaging sectors. And all our customers have setting their own ambitious CO2 reduction targets, and we must be mindful and take heed of those. And further, many governments, including in the UK, but globally too, they've set objectives to reach net zero emissions by 2050, and in some cases slightly different timescales, but round about that. And then there's a couple of other drivers around Tata Steel's own global ambitions to become CO2 neutral steelmaker by 2045, circular economy, and the UK position around scrap. But I'm going to focus mostly on those points in bold around the market and customer drivers and through government's public procurement. Next slide, please. Just a very brief recap on some of the main decarbonisation technologies being considered by steelmakers around the world. We've got things like carbon capture, utilisation and storage. We've got things like hydrogen-based steelmaking, and we've got scrap, as we've heard, as being a very important decarbonisation lever. And we've got various combinations of those. And there's no one size fits all solution. The different solutions will apply in different regions according to resources like cheap electricity, like green hydrogen, and so on. But in the UK, as we'll see, the main imperative, or the main movement is around using scrap and electric arc furnace as the decarbonisation approach. Next slide, please. Cameron's already touched on this. Why can't all steel be made from scrap? And this graph shows the reason why. Really, there's this lag in scrap becoming available at end of life to be made into new steel because of the durability of steel itself, a great circularity feature. So you get this lag between demand for new steel and availability of scrap, and even out to 2050 and probably the end of the century, as others have already said, there's going to be this ongoing requirement for ore-based metallics to meet the demand that can't be met by recycling scrap, even though scrap at end of life is very well recovered at end of life, very high recovery rates. But there is a point that's already been made about the gains that can still be made by improving those recovery rates at end of life, thinking about end of life, greater segregation, designing with end of life in mind. Very important points. Just on the text there on the right hand side, there's some context around the UK at the moment, because the UK is a relatively mature economy and it doesn't have a lot of arc furnace capacity at the current time. The UK is a significant exporter of ferrous scrap. There's a net flow of scrap out of the UK. Okay, next slide, please. So yeah, scrap is a strategic resource in the UK, and for that reason, Tata Steel is going down the route of transforming its steelmaking assets in the UK, installing an electric arc furnace at its facilities in South Wales, not too far from where Cameron is located. That arc furnace has been mentioned already, is been designed to use an element of ore-based metallics as well as scrap, but will be predominantly scrap fed. And there's various other investments there which I won't go into as part of the overall plan, but that arc furnace is currently been well under development and installation in the UK as we speak. Okay, next slide, please. Right. So what does this mean in terms then of our customer perspective? Very clearly, I think to most customers and users of steel, the steel that they buy, that our customers buy from steel companies, forms a large part of their Scope 3 emissions. So when our customers are looking to set their own decarbonisation targets, they're looking very closely at the purchase goods and services, where that includes steel. If you go to the next slide, this shows it in graphical form. So not so much focus on the left-hand bar, which is a blast furnace sort of breakdown of Scope 1, 2, and 3 emissions, but the four to the right show how significant Scope 3 emissions are in different sort of market sectors and steel applications. The dark blue bar being Scope 3 purchase goods and services in sectors like packaging, like electrical and engineering sector, like construction and automotive, and the steel forms a large part of that. So there's a huge focus from our customers in what are we doing to reduce those Scope 3 emissions, and how do we measure progress? If our customers are setting targets, how do we measure our progress against those targets? Okay, so next slide, please. Now, one way in which, or an important pillar in discussing how in the measurement and verification and tracking of progress towards those targets is in setting rules and guidelines. And this slide really shows how crowded a landscape that is becoming in terms of initiatives that are looking to set guidelines, rules, standards for measuring product carbon footprints and other environmental parameters along the steel supply chain. Some of these are regional, some of these are market sector focused, some of these are kind of regulatory government kind of things. Some are international standards like ISO and so on. But it's hugely crowded, and a lot of organisations trying to determine or feed into how product carbon footprint information essentially should be transferred along the supply chain from steelmaker to customer, essentially. And then just one more click, we'll bring up one of the responses to that. There's really a lot of endeavour, a lot of work going on to sort of harmonise across these rules, these guidelines, these standards, and one manifestation of that is a World Trade Organization-led initiative, along with many other partners, including World Steel Association and Tata Steel. Many other steel makers and so on have endorsed the steel standards principles, which really is calling for the establishment of common methodologies for measuring greenhouse gas emissions, product carbon footprint along the supply chain. That's something that's a really important piece of work, and is features at things like the COP Conference of the Parties meetings every year, updates on that sort of thing. So then, just to go into a little bit more detail, next slide, please. So yeah, some of those elements, as I've said, some customers are setting their own targets, requesting carbon emissions data from their suppliers, from the steelmakers like ourselves, and these include things like Science-Based Target Initiative, things like Responsible Steel, things like Low Emission Steel Standard (LESS), things like the Global Steel Climate Council. They're all ways in which some of those guidelines and standards, and ways in which the measurement of low carbon low emission steel can be sort of demonstrated. Just some, often these are around a 2030 target, maybe 50% less carbon emissions by 2030 from some baseline. So yeah, and for example, just to highlight one there, Steel Zero. That's a construction focused commitment. The members of Steel Zero will have committed, in order to be a member, have committed to buying 50% of their steel that they use in construction products should be low carbon emission steel by Responsible Steel's definition of that by 2030, and 100% of the steel that they buy for their projects should be net zero steel, low emission steel by 2050, just as one example. And then next slide shows some further examples where this has been these kind of classifications, these standards have been incorporated into more sort of legislative aspects or regulatory public procurement type of thinking. So again, just looking at Responsible Steel and less as two examples. There are others, like I say, like Global Steel Climate Council, where these have been written into kind of EU consultations, UK government consultations around how to define really low carbon emissions products. So very much customer demand through those aspects I showed on the previous slide, and then through on this slide more around public procurements and legislation and so on. And next slide, just one sort of further complication, if you like, into the way in which standards are being developed. And that is chain of custody models. And these are very much a hot topic at the moment. Chain of custody models, people will be familiar with perhaps how things like green electricity are provided through chain of custody models. Things like bio-based inputs are presented through chain of custody models in the chemicals and plastics industry, for example. And there's a lot of discussion about in areas including the steel sector about how these models might be applied to account or offer low carbon emissions steel to help with investments for future decarbonisation. It's very much a live topic that is part of that broader discussion around harmonisation. And then final slide. Behind all of that is the need for really credible carbon footprint information, transparency, and this is where things like environmental product declarations and environmental profiles, third-party verified, need to be really clear about what methods have been used and be totally transparent about that. And that's me. Back to you, Cameron.
Thank you so much, Peter. So what I'll try to do now then, acknowledging that we're a little behind time, I'll try to go through this relatively quickly. So we've had a sort of we understand a little bit about the UN mission and why it's so important. We've understood a little bit about the tools, and then we've got some details across the supply chain around the challenges, but also the opportunities that exist in this space. So what I want to talk about now is ways in which this can be applied using those tools, managed and also monitored using those tools as well. So next slide, please. So I probably should have said this before, but a lot of this work is stuff that's done by my wider team, and Ulrich Kral, who's on the call here, will be joining the panel later on, and he's the real expert in this area, so you can ask him some questions later. So this is a slide from one of our partners within the SRM at Exeter, and they've really done a lot of the early work looking at how the UNRMS can be applied to different scenarios. Most of those scenarios up until this point have been in the area of critical minerals from primary sources. And really, you can split this up into three different parts. So the first one is you need to determine what your priority is. So I'll talk about that in the context of steelmaking in just a second. Then finally, secondly, sorry, you need to look at the fundamental principles of the resource management system itself. So how do we look at the responsibility to the environment, our social responsibilities, what practices we need to encourage to look at the circular economy solutions that have been proposed already as part of these talks. And then finally, the governance. And the governance is kind of like just popping out the UNFC, which was introduced earlier on in the talks. And this block diagram here is essentially just a way of being able to visualize that. So the codified approach that Ulrich was describing can be plotted in 3 dimensions across the 3 different axes. So that's essentially what you're seeing here. And ultimately, this has to be underpinned by transparency in how we report the resources and potentially innovation to solve some of the challenges. From the perspective of competency and capability, well, that's what the ICE SRM is effectively here to do, is to communicate to you the requirements, but also we have strong competency in these areas to be able to support people to do these sorts of assessments and management practices into the future. Next slide, please. How does this apply to the question at hand? The good news is I don't have to repeat a lot of the things that people have already said, and you should be well grounded now in some of the challenges and opportunities that exist. My summary of this is, if you start from the left-hand side of this slide at the top and move along to the right-hand side, is effectively that our method of managing this up until this point has been that we have been really good at producing loads and loads of products. Moving along, that means that get harder to produce because they become more advanced and the tolerances in the manufacturing process gets less. So over a period of time, our room for error gets smaller in producing steel alloys. And the current problem that we have at the moment is that if we put all of this into a large pile, as both Antonia and Jeremy have pointed out, then you end up mixing a lot of different things together, and that can result in these residual elements that Jeremy was talking about. If we set our priority for the resource management system to be maintaining these sources at high quality over the next 30 to 40 years, we need to do significant interventions in both the product space and the design space, but also in the end of life space if we're going to solve this problem. Next slide, please. So how do we do that? Well, the first thing is that if we just look at that middle part at the top there, we need to reverse this product development trend. The first thing that we need to do is we need to look at redesigning our alloys to make them more resilient and make them more robust, so that where we do have higher levels of contamination coming in through increased levels of recycling, we are able to manage that better. And that means we need to increase our room for maneuver. So we need to approach it from that end. Moving along to the right-hand side of the slide, we do need to stop packing everything into a pile and then recirculating those elements across the top. And so to embed this sort of circularity, what we need to do is collect more data. So this is around those transparency and service orientation elements of the resource management system. And there are lots of initiatives that I'm not going to go into detail here today because unfortunately we don't have the time, are looking at how you can manage data across the supply chains more effectively. Peter alluded to some of them in his previous talk, but there are others around the construction product regulation, for example, the battery passport that's coming through within the EU, where we're looking at both mandated but also voluntary approaches to tracking data as it goes through the supply chain. On the proviso that we get that part of our resource management system correct, that allows us to do the value addition and the resource recovery that have been discussed in previous talks. Really, we need to separate out these components of the scrap and send the elements where they need to go. So if you want to produce a car, you kind of need a lot of iron, but not much else in relative terms. If you want to produce a small modular nuclear reactor in your Rolls-Royce, for example, then you're probably going to want some iron, some nickel, and some chrome. We could be better at managing this process if we take effective management strategies and management strategies. Look at that. So this is kind of the structure that we can use within the UNRMS to be able to manage this new ecosystem, test it, and see how it's performing. But to do that and deliver it effectively, we need to get the governance right. So next slide, please. Well, I'm just going to quickly zip through some examples of how we're using some of the information that we've collected both within my group, but also it's similar to some of the work that's been presented by other presenters today, and fits into that governance piece, which is kind of managed through the UN framework classification. So I'm going to talk through the 3 different one example from each of the 3 different axes very, very quickly to save time. So the first one is around the technical side, and Jeremy's already told the story really, but effectively, Richard has also been out and about across the world looking at different sorting and separation practices. and looked at all of the different methods of processing, reprocessing, how many times you need to process the material. Antonia talks about that as well. And effectively, we've reached the same conclusion as Jeremy, which is heartening, which is that the technical feasibility is actually really high. And so, you know, this is effectively an F1 project wherever you want to go because the technologies exist. Next slide, please. Let's now consider the E-axis and look at the economic approach. Well, now this is where things get complicated, has already been alluded to by previous speakers. So actually, it changes by region significantly as a function of the local electricity price. So there's an example in the figure of price disparity between the EU and the UK, for example, UK steel data. It changes significantly as a function of the supply chain configuration. So are you vertically integrated? Are you just buying from the market? Do you have a different, a JV or something? So the way that you configure your supply chain and manage the flow of your material, what's the strength of the relationship with your customers? And then finally, of course, as a function of these different places where you are, there are very different policy costs depending on where you're operating. So the E-axis score can be 1 in certain places, it can be 2 in others. There's definitely potential. It wouldn't score any lower than that, but there are some issues to overcome. Next slide, please. And then G, this is where it gets even more complicated. So now, just remember looking at the resource availability. And for mining, this is kind of easy, but for, well, not easy actually, but I mean, it's easier than it is for anthropogenic resources. The reserves that exist for anthropogenic resources will change with the interest rate. So if the interest rates go up and the purchasing power goes down, people are less likely to allow stuff to reach the end of life, and then the availability of scrap will decrease. So it's not like looking at a mine where you've kind of got given reserves. But even within that, we've already seen these challenges that exist around how you monitor the quality of that material. There are 2 approaches which we've examined. One on the left-hand side is confidence and estimate. This is effectively where you build an inventory of material across, in our case, for our study, the UK, and look as a function of our consumption and production tendency within the UK, roughly what level of intrinsic copper, so this is copper contamination within the material itself, not the material that's the free copper that Jeremy mentioned earlier on. That's one way. The other way is to simply dig into the pile and start measuring. And that's also something that we've started to do. And the key point I suppose to make here is that if you look at the whole pile as one distribution, it becomes extremely difficult to do. But if you look at this as a function of a compound distribution where you're looking at individual constituents of that pile, it becomes slightly easier to do, and you get finer distributions which allow you to be able to predict what the elemental flow might be into the future. So comparing one to the other, you get good agreement, and that gives us confidence. So moving on. The potential impact of this, of course, is that you can reverse this process. So you can apply your model of the distribution compared to the composition, superimpose that back on your pile, and then actually proactively select material from that, and then try to generate a composition. At a scientific level, this is something we've attempted in the lab. The results are presented below for one alloy. No ferroalloys were used for this at all. This is all just on the basis of the composition of the scrap that was charged. And the potential benefits here are reduced levels of ore-based metallics, increased resilience for the process and your supply chain itself, and the reduced use of ferroalloys, which can be critical materials, as Ulrich pointed out earlier on. Next slide, please. And this ultimately has significant decarbonisation benefits, which change as a function of the type of product that you're looking to try to produce. So by connecting the composition requirements of the products to the potential interventions in the recycling space, you can start to understand from an E-axis and environmental perspective what sort of benefits you would likely to get. And you can roll all of this up into the UNFC and the UNRMS and help that to support you to make decisions and assess your projects. Next slide, please. I'm going to skip over this one just in the interest of time, but that's the detail behind how it was achieved, which I'm happy to try to address in a question if that sparks some interest. So in summary, I'd like to say that a holistically sustainable solution to steelmaking is not simple. And when I say holistic, I mean both environmentally sustainable and economically sustainable. Resource management practices that overlook this complexity will never deliver that holistic sustainability. But the UNFC and UNRS are unified and internationally recognized tools that help us to capture this detail without having to present it continually to everybody all the time when trying to make the decisions. And so we at the ICE SRM are here to help and support you to try to achieve that. That draws all of the presentations to a close, and now next slide, I think we'll be moving on to the panel discussion. So I will just open up the Q&A, and thank you for anybody who's already pulled in some questions. So I'm going to go straight to the floor. So everybody to turn on their screens and unmute themselves. That would be great as well, just so we can have an open conversation. That would be fantastic. So there were some comments that were made earlier on, I think, by both Jeremy and Antonia, and we've got a question here from Erica, which is, can the free copper in scrap be considered a business opportunity? I know Antonia alluded to this in her talk. There are copper deposits in Europe that are mined economically in Europe today with, say, 0.15 to 0.2% copper. Is it partly a regulation problem why this isn't already happening? And if so, what bottlenecks could we look into to try to overcome this? So, Jeremy or Antonia, perhaps you want to have a go.
You go first, Antonia, and then I'll
Okay. I think it's being a new. I don't think it's a new business opportunity. It's already being done. Copper is far more valuable than steel, so we want to get every last drop we can get. We don't want to have copper in the ferrous that we're sending to steel mills. So I think it's already there, but the issue is when it's not pull-outable. But there's also the issue that we in the UK, in Europe, we have the issue with copper fines being deemed hazardous, which loads extra costs now onto recyclers who will have to have different permits potentially. So I think it's already being done. So I'm not sure the value of making it a new business opportunity.
Okay, thank you.
I would say that there's several different aspects to this. So some copper, the very fine material, as Antonia says, very difficult to collect and recycle. But that's why there needs to be much more emphasis on product end of life to make it easy to remove those particular components, the small motors that control your windows and different things in an automobile, and get to that point where you can strip down a lot of things. Now, in North America, we're lucky. We've got lots of space. So we have these huge collection yards, which we call picking yards, where automobiles, when they reach end of life, they first go to a picking yard, and people go in there and scavenge parts off of them in order to keep their car running. And then after it's aged for a certain period of time there, also in that location, they remove all the fluids. They remove anything like mercury, which shouldn't be in automobiles anymore anyway, but and the glass and other things. And so we're really doing sort of a preparation stage there in order to set up the shredding operation to be more effective. And we're fortunate in that we have the space available for that in some places. That's not a luxury that everybody has. So there are different factors here. But we should be attempting to move in that direction where we do get those clean recycle streams. And if you look at some of the automotive companies, well, Mercedes has a certified used parts program now, where they actually take end-of-life vehicles and they take parts off of them that still have useful life, and they sell those as certified used parts. So that demonstrates that it's possible. And but when I talked to like Volkswagen, they said, yes, we're very much in favor of this, as long as it has no impact on the cost of the car. So, yeah, that's the dilemma. Everyone's focused on, we still don't have sort of a global perspective. Everyone that's in that circle has to get on board in order to make it work.
Sure. Yeah. And Richard, I wondered if you could come in here and also address a question from Anna as well, about similar principles, but more for zinc. So what are the environmental benefits for dezinking material? And similar from an organic heating perspective as well. So I wonder if I can get you to have a look at both the copper side and the zinc, just to address Anna's question.
Yeah, to make a comment on the copper as well, it's not like copper isn't removed. I think it's roughly, if you look at automotive, and Jeremy might back me up or shake his head at this, but you're talking about you're going from like 2 to 4% maybe of the material that comes through from a car is copper, and then they through traditional processing that we have now, magnetic separation, shredding, we're removing like 95% of that, and it is just that 5% that's left that's causing the problem. And fines tend to stick as well and can be carried through. But I think that we do need to look at better methods, and sizing of scrap shredding. That's definitely one of the ways that we can extract more of the copper, and we definitely need to do more of that. Given that 1 kilogram of copper per ton of steel is enough to raise it by a weight percent point. So it depends on the price of copper, price of energy as well. But business opportunity wise, it's possible, I suppose, but who knows? With the zinc, yes, zinc is, it's a very valuable material as well. And I think that, if we could do some form of stripping before it goes into the furnace, that to me is far better than creating a dust and then extracting the zinc from a percentage of that dust once it reaches a certain level, because obviously zinc oxide is quite toxic, and like with the copper in Europe, it's quite a difficult thing to handle environmentally for companies. So yeah, I think that de-zinking is definitely something we need to do. It makes our cars last a lot longer, but it causes a lot more problems when we're recycling the material.
Thank you. I just wanted to tail into the next question, which was which I'll put to Ulrich, if that's okay for now, and then please everybody else jump in if you need to. This aligns well, Ulrich, with your talk around the interdependency that exists between critical raw materials and steel, and I guess my point of interest there is that steel is the largest consumer of most of those metallic critical raw materials. I think almost all of them except for aluminium. So that you use more. My favourite fact is you use more titanium in the steel industry than you do in the titanium industry, for example. So I was just wondering, in your capacity as chair of the Anthropogenic Resources Working Group, what can these two communities learn from each other? Because they're quite different models we're looking at here between the linear sort of mining approach and the recycling approach, but there's this strong interdependency between the two. So what can we learn from each other, do you think?
Right. I think 2 comments on this. I think if you want to enhance the recycling of scrap or even enhance it by increasing the quality, you need a recycling project. And I think this perfectly fits with the UNFC. But it's not only about technical issues. I think you need the government who provides the framework conditions for these recycling projects, and these framework conditions can also be adapted. Let's just say. So the second stakeholder group, I think, is of course the industry that provides the technology and the capability to enable these recycling projects in practice. And the third one are the capital allocators who provide the investments either for new recycling projects or for upgrading the technology. And I think the EHRM as an expert group of resource management at the UNECE is an ideal platform to bring these 3 stakeholder groups together. And I think what the EHRM can offer in general, and the Anthropogenic Resource Group in specific, is to introduce at the higher technical detail the functionalities of the UNFC in order to develop a case study together with actors from the steel industry. So what you have shown us already for the UNFC and structuring the information according to the 3 criteria, environmental, socioeconomic viability, technical feasibility, and the degree of confidence in the product estimates, right? This is already a great work that also has already been done. Yeah. So maybe we can work on this in the future. Where we bring together the methodological knowledge from the Anthropogenic Resource Working Group together with the domain-specific knowledge from your side or from the steel industry. And I've seen that you already developed 4 different scenarios, I think, and think that this perfectly fits into the UNECE framework of the UNFC. because it depends on the objective of the recycling project. Are we just doing business as usual? Then we have viable projects. That's not the case. I mean, there are viable recycling projects in the industry, but how to come to a higher level of quality in steel recycling? There we have some barriers. You already mentioned them, the dirt of scrap and all this stuff. So these projects are currently potentially viable or even non-viable. And to communicate the barriers, right, of the non-viable projects and the potentially viable projects, I think this really has an added value. Yeah. So not focusing on the projects that are currently ongoing, right, because they are in practice, I mean, they are based on an economic viable basis. But I think looking into these projects which are currently potentially viable, non-viable, right? And to address these barriers and to communicate this in a standardized manner with the UNECE to allow other stakeholders like government and capital allocators to understand the barriers. Yeah. And I think there we can still closely work together, and it would be great. Yeah.
Thank you, Ulrich. This relates to another question, which was around the customer perspective that I wanted to bring Peter in on, which was around this perception of green steel, a very loose definition, right? From the customer perspective. And we shouldn't expect them to understand all of the complexity that we've only begun to introduce in this webinar, of course. But I was just thinking about, based on what Ulrich was just saying there as well, this sort of common reference framework or a way of being able to understand the complexity without having to get necessarily into the weeds or identify those barriers without having to have the domain expertise. I was wondering if this might help diffuse things. You were talking also about the collective work that's going on across all these different initiatives in the green steel space.
Yeah, definitely, Cameron. Green steel is a useful term, isn't it? It has a broad, people kind of broadly understand what it means. So yeah, and we've had a big debate about how we should use the term green steel in all our geographies across with our Indian, Dutch, UK colleagues about how should we use green steel, if we should use it at all. And it does have, the conclusion of that was it does have some use when we're talking to the likes of politicians, to media, to local communities, because it kind of gives a sense of our journey, that we're heading in a certain direction. But when it comes to discussions with customers in particular and around products where things are a little bit more contractual, a bit more formal, a bit more based on a specification, let's say, then really we decided we shouldn't use the term green steel to describe a product unless that comes along with a very clear definition of what we mean. And in fact, we kind of use the term low emission steel if we're thinking about CO2 emissions. To me, green steel means something, or the term green means a whole lot of things that are not just about CO2. It's more a broader set of sustainability criteria. So we focus more on using the term low emission steel when we're talking about our products, and then that comes back to some of those standards, guidelines, and definitions that I talked about earlier that help to with a methodology, with some clear scope and so on behind it, maybe puts things into like a band, a bit like the way in the UK and I think in many other countries around the world that energy intensive products are put into like an A-rated product or a B-rated product and that sort of thing. So I think that those are some of the ways that the standards are working towards, with an eye on communication to the end consumer.
And I think my reflection on this is that obviously there's risks for everybody if we manage this poorly. So customers will get products that don't function, and we'll end up from the supplier side, you'll end up with products that you can't sell. And so a way of being able to communicate the potential barriers of I've got this feeling in the UK at the moment, taking that as one example, that we have the potential to crash into circularity without effective management, and I think trying to use tools like this that would be able to highlight to people why there is a challenge, why it's important for all of these things to be right, that Ulrich was mentioning as well, and communicate that clearly. I think that's a way of being able to manage what might otherwise be viewed as a tension, because ultimately, we can't do the circularity at the front end without the support of the customers. The customers aren't going to get the decarbonised products and also more resilient supply chains, potentially local supply chains that they need, unless we work together on solving the problem.
Yeah, totally. And if things are confusing or not, and there's no transparency, then that creates problems and possibly to accusations of greenwashing and that sort of thing. So you need to avoid.
So I was just going to ask, we're heading towards the end of our time here today, unfortunately, but really welcome all the contributions that have been made. But I just wanted to provide one last opportunity for the panel to go around. And, my perspective, based on what we've discussed today, is that, you'd think melting metal would be simple, right? You just got to heat it up and everything will be fine. You make it into something else. I think what we presented here today is that this is incredibly complicated, and also how you manage this and other similar problems in resources is also a difficult beast to wrestle. But my perspective is that sort of unified tools like the UNECE, UNRMS, and all of the expertise that are required to use them make this picture a little bit more accessible and easier to manage without necessarily getting into the weeds of the problem every single time you want to communicate with somebody about it. I was just wondering whether you think these are things that would be helpful to you in the interactions that you have, through the supply chains or supporting, people who want to transform, and whether or not you could see a use for that from your side. Any closing comments really on that from the panel would be great.
I think anything that provides greater clarity is useful. I think we're still very much in what I call an educational stage, where we're trying to educate all of the people that are in that circle, as I said, and then getting them aligned. So it's a bit like what you go through on any project. You've got a bunch of people all trying to do something, but you have to get them aligned so that their efforts are used in an optimal way. And so it's sort of one part of the overall picture, along with additional education, getting the steel industry, the customers, and the recyclers all sort of aligned. And this is where you get into, there's a cost saving for the steelmaker when they have better quality scrap. So they should be willing to pay a little bit more for that, so that the scrap processor shares a bit in that. And obviously the customer who's demanding the steel also recognizes, there's additional effort going on here. And so things sort of balance out. That way everyone wins, and we move forward, and we're doing something which should be obvious to everyone is the right thing to do.
Thank you, Jeremy. Any brief comments to follow up from anybody else, or some closing thoughts that they wanted to make before I round out the discussion?
Yeah, I'd agree with that, Cameron. I think there's a need for clarity and transparency, and then some of the other key points that we've heard around kind of investments in facilities, in thinking about end of life, right through the whole design process, all through the supply chain. I think those are important points that will help us close the loop, close the circularity loop more effectively than we already do. Thank you.
Thank you, Peter. You've managed to close out the whole of the webinar. I'd just like to thank everybody for joining. I extend my thanks again to all of the panel members who've come to discuss with us this important topic with us today. The recording for this webinar will be available on the ICE-SRM, the UK ICE SRM website. And we'll be circulating links to that for all of the attendees who come, so they can come and have a look at that again. Thank you very much to everybody for all of their contributions. We've just about managed to finish on time. I'd like to thank the presenters for helping with that as well, because it's an extremely challenging timeline with all of those different perspectives to draw in as well. So if you want to know more about the UNECE and the UNRMS, please do visit either the UN web pages or get in touch with us at the International Centre of Excellence. We'll be more than happy to support you on your circularity journey. Thank you very much for attending.